So we're delighted to have our team of experts back on our jury for this track. As questions arise, can I remind you, please, to introduce yourselves when you take the microphone before you ask your questions. Thank you. Remember the rules. You have 3 minutes for your pitch and 2 minutes for jury questions, okay? So let's get started. Give a warm welcome to the first presenter, Thiago Figueiredo, co-founder and CBO at 1S1 Energy. Remember, so you have 3 minutes. Good luck.
Thank you. Can you hear me? Hi. So yeah, we're working on breakthrough PEM technology for both electrolysis and also developing fuel cell components along the way. So I mean, I think this crowd here knows that electrolyzers are rather unreliable, use way too much electricity, not durable, and also very expensive at the moment. And again, I'm probably not the first startup to tell you, and others will come that will say, essentially, you know, this can be done, and you'll be a bit skeptical. So just bear with me 2 minutes. So what's so special about 1S1 Energy? So when we looked at the problem with PM, by the way, we figured out that everybody's kind of tackling the symptoms of the issues that are associated with PM, but we didn't see much people actually targeting what's one of the root causes of what caused this. And these root causes are actually the proton exchange groups. And essentially, we managed to find new ones, patented, and they actually work quite well, allowing us to completely rethink the electrochemical cell. So we're working on all the components ourselves and developing a vertically integrated electrolyzer based upon the element boron. By the way, we're not a spin-off of anywhere, so all IP is controlled by the company. So, I mean, simply, if you want an electrolyzer, what you want to see is the least amount of electricity used at the highest possible throughput, so you have a smaller system. So today we already meet the goals for Europe in 2030, and our projections suggest we can go much lower than that with generation 1 and generation 2, which is a high temperature. So today when we look at the market, you have either traditional PM, uses way too much electricity to get but operates a high throughput, or some other technologies seem cool, but actually in electricity use, but don't tell the whole picture. These are going to be massive systems with this kind of throughput. So in terms of business development, what we're doing is we're piloting this. Our first pilot is a large electrochemical area with Enel Green Power and Polytechnico Torino, and we're just going to sign a pilot of 2.2 million with a steel and utility company to go from a 6 kilowatt all the way to 100 kilowatts, which is the basis for our modularized solution, which is this 1 megawatt module here in the right that can be put into any size of operation. So because we're vertically integrated, some of the components actually work on fuel cells, and for the past 3 years, we've been working with chemical companies and fuel cell companies to potentially license or sell the components to them. So this is us. Dan and Sukanta, CEO, CTO, have been working together for the past 15 years, finish each other's sentences, build companies, license technologies. I built and sold a business before 1S1 Energy, so we do bring some interesting experience in the entrepreneurial side, but also in the academic side, you know, in developing novel technology. So where we are now, we are closing, actually this week, hopefully we're just signing the first closing of our seed of 1.5 million. And this is the building that actually we are about to rent. And the idea is we would raise up to 1.5 million. We're not too fussed about it because the pilot, you know, is an interesting non-dilutive way to fund our stack development. But obviously we would invite strategic investors. And it's pretty simple. We're going to develop our own infrastructure, you know, go to 100 kilowatts, you know, be able to achieve high temperature PM and also additional revenue. Thank you for your time, and please reach out.
Thank you. Jury, you have 2 minutes for questions, please. No questions for this young man? No? Yes? Thank you, sir.
Thanks for the pitch. Can you tell us a little bit more on the competitive advantage to your competitors out there that work on the same thing?
Sure. So I mean, I think that the field is very broad, so you have different flavors of electrolysis. We've chosen PM, honestly, because we believe it has the best fundamentals. So it pairs better with renewables. You can operate at a very high throughput, so you can have a smaller system, and theoretically, it can increase the efficiency of the cell quite a lot. So, and this is what we're working for. So essentially what we see now is that we managed to show that we can increase the proton conductivity. Is a little bit technical, but essentially improving the cell efficiency. We also are able to improve durability by kicking out the form of proton exchange groups of ours, but we have several other innovations that we want to work with, and we're just scratching the surface. So the whole point for us is like we want to build the best electrolyzer that uses the least amount of energy, but also at a highest possible throughput, so you have a smaller system. So that's how we believe we're going to compete. It's not just one or the other, it's actually being able to achieve both. And the second generation of our tech is when we go to high temperatures, and this will even lower the electricity use beyond what people call the 100% barrier, and that's what we're working on. It started to test that in Italy for fuel cells at the moment.
Thanks.
Any more questions? Then thank you very much, sir. Next up, we have Gabrielius Sitas, business developer at ETB Global B.V. Remember, you have 3 minutes, sir. Good luck.
Hello, everyone. Thank you for the introduction. It's a pleasure to be on the stage. Today, I'm going to introduce you ETB Global, a technology developer for bio-based butadiene. First of all, what is butadiene? Butadiene is a building block for rubber and plastic industry, and it's used in a variety of products, from Lego bricks, latex gloves, tires, and even perfume. However, the problem with the conventional butadiene comes from the roots of its production. It is produced using fossil-based feedstock, which emits more than 30 million tons of CO2 on an annual basis. This is equivalent as annual emissions of more than 6 million gasoline cars. ETB Global offers a solution. We innovated a way of transforming bio-based ethanol into bio-based butadiene through a one-step catalytic conversion. Not only do we offer a drop-in molecule that does not disrupt the value chain, but most importantly, we cut the CO2 emissions by 60%, and we reduce the energy consumption by 2/3 compared to the conventional way. And the market demand is clear. Taking, for example, one of the largest butadiene users in the world, tire manufacturing industry, they have a clear goal to have green tires by 2030. They know, and we know, they cannot do it without bio-based butadiene. And that's why we are accelerating through the steps of our development. We have our pilot plant up and running. We're on the verge of building our demo plant, and these steps will take us to the final technology de-risking and make us build our first commercial plant. Of course, our ambition to bring the technology to the market has not been without recognition. One of the biggest milestones we achieved was last year, where we got €5 million grant from GTF European Fund that will help us build our demo plant. And of course, the development would not be possible without our team. Together, we hold more than 100 years of experience within the catalytic and petrochemical industry. So the question is, who is ready to join our pathway to decarbonization and make bio-based butadiene available together? Thank you.
Jury, 2 minutes for your questions, please.
You mentioned that your process is 60% less GHG intense than conventional processing methods. How much of that is because of your actual process, and how much of that is predicated on the use of green ethanol?
So most of the emissions come from the feedstock, right? So that's where we aim to reduce it, and that's where we reduce the emissions. And the process itself also reduces the emissions just because we cut the energy consumption and we use one step instead of two-step.
Thank you.
Thanks for the pitch. How much, or what else can you do after the first material with the technologies? Do you have the potential to build a platform in that way, to have more materials? Or what are the next markets that you tackle?
Good question. Thank you. Indeed, we focus on bio-based butadiene. That's where our effort is going towards. But we also have an opportunity to valorize hydrogen. There's not the biggest amount of hydrogen coming out, but there is a potential in the future.
Do you currently meet industry standard in terms of purity and the grade of the actual material that you produce?
So yes, we do, and currently we're trying to excel or accelerate and big it on a scale version so that it could be tested and any necessary steps would be taken to actually prove the purity and everything that's needed.
Can you give us a sense of the challenges on the qualification of the product and how many potential clients have they qualified the product and validated that they fit on their process?
Sorry, could you repeat?
So your customers, I'm sure they need to qualify the product as you have it and you send samples. Can you tell us a little bit about that traction?
So we're in the process of doing so. The main advantage is as well that we can use the same purification process as are used today. So we lowering the capex investments necessary, and on paper it looks great. So the purification is going on further as well with our strategic partners.
Thank you very much.
Thank you.
Thank you. Next up is Belén Moreno, Account Executive at HSL Technologies. Remember, you have 3 minutes. Good luck.
Thank you very much. Thank you very much for the opportunity of explaining what we do. We are the green molecules track. So green molecules is definitely linked to green transition, energy transition. For us, energy transition would not exist without the social transition. That's what we have considered at HSL Technologies. My name is Belén Moreno, and I'm account executive, and I'm going to explain to you how we have conceived this way to transport hydrogen and store it as any liquid. Hydrogen today is actually a key element to reduce the fossil fuels to zero, to use new technologies such as hydrogen, but it remains something complex and expensive because of its transportation and storage. The methods today either need a very high pressure or a low temperature, and most important, we do not have the infrastructure to do this transportation. That's why at HSL Technologies, we have conceived a new way to store and transport hydrogen. This is actually a technology that consists on charging hydrogen into a silicon molecule, which is a non-organic basis. That means that it's zero carbon. And once we have done this, we are going to create a new molecule. This new molecule, which is called HydroSeal, is going to behave very similarly to hydrocarbons. Actually, it's going to reuse all the infrastructure which is linked to them today. That means that we are over with investing in infrastructure. We are going to reuse the infrastructure, and most importantly, we're going to reuse employment linked to this sector today. And this also is going to reduce the trucks on the road for hydrogen transportation. And the most innovative part of it all is going to be the fact that by just combining the solution with water, we are going to get the hydrogen out of it for its usage. That means that we can actually bring hydrogen from places where we are going to produce it at very cheap price to places where energy is not available. This, of course, is going to regroup hydrogen producers and is going to approach their offer to the hydrogen consumers' demands, all by partnering with logistics and producers companies that are willing to communicate with companies willing to transport in overseas, willing to develop mobility, and companies willing to store long-term. All this by using our solutions. And this, of course, is reinforced by an amazing 28 talents and a financial ecosystem that firmly believes on what we do. Today, we are partnering with them not only in terms of investment, but also in terms of co-development and business development. That's why we already have some pilots ongoing and are going to build some new ones in the next year, aiming to do a Series B in 2027 from now on. So if you are willing to join us on the energy transition coupled to the social transition, we are here at HSL Technologies. Thank you.
Thank you. Jury members, you have 2 minutes for your questions.
Can you give us a sense of the energy consumption of going into the liquid and then converting it back?
Yeah, so indeed, unlike any other hydrogen carrier, we are going to have the energy consumption at the point of charging, the fact of combining hydrogen with the common silica and creating the HydroSeal. We are going to have a little energy consumption there, which is actually going to be something we are going to recover at the point of arrival, because our reaction is going to be exothermal at the point of arrival. That means that the reaction is going to have 26 kilowatt hours that we are going to recover at the point of the arrival. That means we are spending indeed energy where it's available at the hydrogen production site, and we are going to re-employ it at the other point where potentially we will not have energy not only to use but to valorize.
And apart from the energy consumption there, when you look at the whole process or scaled up, what does it do to the cost of green hydrogen?
So actually the cost of hydrogen is not something we are going to handle. That's up to hydrogen producers. But that's great because we are only going to add a small fee to that when transporting it. That means that if we think about it, we just have the kilowatt hour energy to think at the point of the charge, and then the transportation is going to cost as much as it costs to transport today diesel or gasoline, because the logistics are the same. That means that among all the hydrogen transportation methods is going to be the most optimized ones in terms of delivery.
Thanks.
Thank you very much. Thank you. Next up is Holly Reeve, CEO at HydRegen. Maybe you have 3 minutes. Good luck.
Hi, thanks. I'm Holly from HydRegen. I'm delighted to be here today to tell you about the impact that we're delivering across the chemical sector. And that really stems from fast-tracking adoption of bio-based manufacturing techniques for more sustainable chemistry. So before we started the company, we went out and spoke to 100 companies across the chemical sector to really get an understanding of the challenges that they were facing. And we used that information to design our business plan and our routes to market. Fundamentally, a lot of these problems that we were seeing came from the use of precious metals in their manufacturing processes as catalysts, leading to a whole range of regulatory, financial, and efficiency problems. So at our core as a company, we are looking to trick chemists into using enzymes. We package enzymes to make them look like metal and carbon catalysts, and that allows us to then make use of the infrastructure that already exists and is already intensified for more bespoke chemical manufacturing. And for the technical chemistry minded, there are some pictures of our products over here, and we're looking now into the kind of cost and carbon savings that these can make across the sector. We are selling these products. We're also carrying out joint development, and that's all there to be designed to make the most valuable manufacturing process we can to then license that out for manufacturing by our customers at the end. And we have good traction now working across the whole chemical sector, from the kind of fine chemical, pharmaceuticals, all the way through to the bulk sector. As an example, to kind of bring it to life, paracetamol is one of the chemicals we're working on. In COVID, the EU was kind of 10 days away from running out of their paracetamol supply, and there's a big political drive to now reshore that manufacturing back in the EU, UK, and America. But the current methods are not really lending themselves nicely to Western production. They rely on these precious metals, they run at very high temperature, very high pressure, and they have a whole range of safety concerns. What we're offering is a bio replacement for that step, for this key step, this hydrogenation step, that allows you to run in the same infrastructure, but at lower temperature, lower pressure, making a safer, cleaner, more sustainable, and ultimately cost-effective process. But this is the kind of strategy we're using for a whole range of chemicals across a huge different number of markets. We have a really great team, of course. We're really delighted to have our chair, Will Barton, who has a huge amount of experience across the chemical sector, from big companies, small companies, and especially in licensing out catalyst technologies. Joe joined our board recently. He has a whole range of pharmaceutical experience, which is really relevant to our kind of first and primary market at the moment. And then our team in general has a huge kind of biology, chemistry, scale-up set of knowledge. So we are seeking £8 million at the moment. That's really to build out our R&D teams, and that helps us take on more joint development work, make those more bespoke processes, and therefore fast track getting to those licensing opportunities. We're not a CapEx expensive company. We outsource enzyme production. We then license out manufacturing. So really it's about creating the value for a particular process. And we are looking to get to break even within 2 years. And at that point, we can then choose whether we ramp or continue ourselves. So yeah, if you can help us in fundraising, making partnerships, or growth, we'd be delighted to talk to you.
Thank you very much. Jury, you have 2 minutes for your questions for the young lady.
Thanks for the first use case. So is there, can you give us a little bit more insight on what else is possible in terms of materials or areas to cover and replace chemicals? So is it pharma, is it new materials, or where is it going?
Yeah, perfect. So what we're doing is hydrogenation chemistry, which accounts for 14% of all chemical steps across all those different sectors. Obviously, the kind of key drivers for what companies are looking for is really different. So in the pharmaceutical sector, there's a much bigger focus on kind of precision and the kind of more complex chemicals, and all the way through to the bulk, where there's way more pressure on the cost and sustainability arguments. The two products we have on market at the moment, one does nitro to amine chemistry, which is pretty big in the materials sector as well, because it kind of helps with making monomers that kind of click together to make polymers. And our other is in making chiral molecules, which is obviously much more relevant to the pharmaceutical sector. But we do have an ongoing partnership in the bulk chemical sector as well at the moment.
I'm assuming that you're going to have to operate under GMP conditions for pharma and qualify the process. How do you see that complexity?
Yeah, so obviously our kind of key strategy is licensing out for manufacture. So ultimately, what we're doing in-house is developing a bespoke process and then working with the customer to do that. And we outsource our enzyme production. So we kind of outsource that aspect of making the enzyme to the right standard as well. Obviously, the first time we go through that process will be more time consuming, but once we get there, the kind of key components should remain quite straightforward for rolling that out longer term. And I think it's something that customers are interested in, is that once proven for one process they have, it's quite easy to then roll out for others. So it is a platform in that way.
Okay, thank you very much indeed. Next up is David Strittmatter, co-founder and CEO of ICODOS GmbH. Remember, you have 3 minutes, and good luck.
Hello, Bilbao. I'm David Strittmatter, co-founder of ICODOS. Shipping and chemistry have a massive problem. They emit 10% of global greenhouse gas emissions. And without sustainable fuels for shipping, and without sustainable platform chemicals, this will not change. These industries have realized this, and consensus has emerged that sustainably produced methanol is a solution. However, today's production technologies are insufficient. They are and will never be able to produce sustainable methanol cost effectively and at scale, because they are inflexible, inefficient, and highly capex intensive. The result, sustainable methanol is at least 3 times as costly as conventional one, and there's a massive supply and demand gap. The solution, ICODOS patented breakthrough e-methanol production technology, enables our customers to produce sustainable methanol at the cost of conventional one and ensure availability, because it provides the highest degree of flexibility to harness the scarce sustainable feedstock sources. I would love explaining this in more detail, but this has to wait for the Q&A or coffee chat later. Our technology was validated 2.5 years ago with a lab plant, and with our last year's commissioned fully integrated e-methanol plant in Karlsruhe, ICODOS is ready for scale-up. Our clear growth path is supported by a massive opportunity pipeline, more than 25 LOIs signed, first paying partnerships with large-scale industrial companies for our first industrial-scale plants, and more than 14 million euro in public financing acquired for our technology. And the opportunity, it's enormous. A total addressable market worth hundreds of billions of euro and a greenhouse gas abatement potential of more than 1 gigaton per year by 2050. In this market, we differentiate ourselves in 2 ways. First, our technology provides our customers with a substantial cost reduction potential due to our protected technology, and B, provides the highest degree of flexibility, not only with regard to the scarce distributed feedstock sources, but also with regard to the plant scale. A clear proof to this is we're the first and only company that has acquired Horizon Europe money, which requires that the technology goes far beyond the state of the art and brings the whole value chain of the industry forward. And the team behind ICODOS is the very right team to bring this forward. I'm a former management consultant, used to work for McKinsey, where I helped climate technology companies to grow. Francisco, our CTO, has more than a decade of experience in R&D, chemical engineering, at the very right spot. And Jens brings more than 2 decades of industry experience to our team, has done multiple times building large-scale chemical plants from concept to fully optimized operation, for example, in China or in Abu Dhabi. And that's it. Thank you so much.
Thank you. Jury, you have 2 minutes for your questions.
Can you tell us something about the technology?
Yeah, the technology, two key innovations. First, a patented protected process that is a new way to approach e-methanol production. So it's really a process starting with point source off gas through the end product, so methanol. And secondly, we enable the whole plant to produce dynamically and fully automated. Point source off gases like biogas, biomass, fermentation off gases, pulp and paper, but also cement, steel, and so on. It's very flexible. In our case, it's a thermocatalytic process. Yeah. It's one reactor system, but it's multi-step. We are working with this BASF together. It's our technology partner.
Where are you in terms of the technological readiness level?
Pilot is TRL 5 to 6. Our demo in France, which we built with EDF, is 7, and with our industrial partners from the oil and gas and energy industry, we're working on the commercial scale, which is 8 to 9.
And then timeline on that?
FID is beginning of next year, mid next year, and construction will be by end of 2025, beginning of 2026.
And then other topic of securing the feedstock that you need.
We see ourselves mainly as a technology provider, but our customers, the producers, oil and gas energy, they have their own assets or close to partnerships. For example, the oil and gas industry works intensely with biogas producers, biomass vendors to secure their green molecules for the supply chain.
Do you have some commercial traction in terms of secured?
Yeah.
Can you share more?
For example, we have a board-approved implementation study with a major oil and gas company. That's confidential for this conversation, but I can tell you the name if we have a coffee chat.
Thank you very much.
Thank you.
Thank you, sir. Next up is Leon Rizzi, CEO of Jolt Activated Electrodes. Remember, sir, you have 3 minutes. Good luck.
Hi. Jolt, we make electrodes, or I should say we do the coating for the electrodes for electrolysis, which means all forms of electrolysis. Traditional, the production of chlorine, purification of water, swimming pools, but also the emerging electrolysis sectors. So we're making electrodes for redox flow batteries, for e-fuels, carbon reduction, and since this is green molecules, also for hydrogen. Now, we can make electrodes, or I should say activated electrodes, for all 4 sectors. Because we are electrochemists, we focused on alkaline and AEM first, because it's a combination of the biggest sector and the biggest growing sector. Now, hydrogen seems to have gone off the boil with the VCs recently. And I'm saying, don't look at the electrolyzers, look at the growth of the market leader, De Nora, in alkaline, and they only make alkaline. Only we can make AEM, by the way. Their market share has gone from 42 million revenues in 2022 to 104 million in 2023. That's a growth of 308% in a year. And if you read their report issued in March, they expect that same growth to continue well beyond 2030. So what problem is there in hydrogen if you make the electrodes? None at all. And by the way, 95% of their orders come from one company, NEOM. And NEOM need to grow another 10 gigawatts in the next couple of years. So if you make the electrodes, there is no issue. Now we have 2 real competitors in the hydrogen sector. In terms of both scalability, volume, speed of delivery, we beat them. Durability, we start at 95% efficiency versus 74.5%. We are the only company that can warrant 10 years with 1 to 2% degradation, and that includes when you use them with renewable energy, which would normally strip the catalyst off an alkaline or an AEM electrode. And we're able to do this with a margin that's 4 to 5 times higher than Denora or Permascand. You can ask me later how. I only have 3 minutes. We're opening our first 4 gigawatt plant. In fact, it's already running. And we've done this in 2 years. April is our 2nd anniversary. We set up the company 2 years ago. We were TLR 3. We're now TLR 9, invoicing customers. A combination of old people like me and very young, smart chemists. And we have excellent commercial traction. We're already about to sign major offtake agreements leading to gigawatt volumes in 2 years' time. Thank you.
Thank you. Thank you very much. Jury, you have 2 minutes for questions.
I think you mentioned you had applications beyond hydrogen and other electrolysis cases. Can you speak a little bit about it and the readiness of other?
Anything that needs an activated electrode, which is putting a catalyst onto a substrate. It could be titanium, carbon, ceramic, polymer. In a one-stage process, we can do it. So vanadium metal air redox flow batteries use activated nickel. We're making those, for example.
Conventionally, these activated catalysts require some kind of binder, which typically is PFAS. How do you see up-and-coming regulation around PFAS representing a risk, if any?
Now, you're talking about the original way electrodes were made, like 100 plus years ago, the 3-stage process. You make the powder, you make the solution, you add the binder to stick it to the substrate. You then get some very expensive equipment to roll it onto the, normally in this case nowadays, it's PEM membrane. Anything with a binder introduces a weakness. When you put that in a stack, that's what leads to your flaking and cracking off of the catalyst, the breaking away of the catalyst from the substrate, which leads to your degradation, and then the electrode dies in 4 or 5 years. Or in the case of a PEM, 20, 25,000 hours, no matter what anyone says. You put a catalyst on a membrane, you stress it. We don't have that problem. With our solution, we're actually fusing, as the catalyst is formed, it's a coating process. It's fused into the top layer of the substrate. It's an exothermal process. It takes about a millisecond. So there's no binders, no cracking, nowhere for the solution to penetrate and begin the process of delamination of the catalyst. Only one catalyst layer. And we have a combination of both PGM-free and PGM-light with 5 times less loading.
Thank you very much.
Thank you.
Thank you. Next up is Todd Brix, co-founder and CEO at OCOchem. Remember, sir, you have 3 minutes. Good luck.
Thank you, and hello. My name is Todd Brix, and I'm going to talk to you today about our formate future and answering the question of basically what do we do with all this CO2 that we're going to be capturing. The fundamental problem that our technology addresses is what to do with all the CO2 that's being captured. Conventional thinking posits that we should capture it, spend a lot of money to bury it, and then get rid of 1 ton of CO2 for every 1 ton of CO2 we capture. We propose instead to not only to take that captured CO2, add value and hydrogen to it, sell it for a profit, and by doing so, generate 7.2 tons more of CO2 abatement benefit for every 1 ton of product that we make and every 1 ton of CO2 that we capture. Our solution is CO2 electrolysis, and we regenerate CO2 into a platform molecule by converting water, CO2, and electricity in a single step in a single electrolyzer device into hydrogen formate, which then can be used and transported as a conventional liquid to either generate on-demand hydrogen, on-demand carbon monoxide, or to synthesize a wide variety of other types of green chemicals and derivatives. Sustainability-wise, relative to the incumbent BASF process, we are carbon negative as opposed to carbon positive in our production of hydrogen formate. Sustainability-wise, hydrogen formate is the only molecule that you can make from CO2 at a lower cost today than any other kind of conventional alternative product that can be made or synthesized from CO2. And this is primarily due to the fact that formate has the highest molecular weight per molecule to the number of electrons per molecule. Any other kind of chemical that one would seek to make from CO2 will inevitably be more expensive relative to the fossil-based version of it today. The markets for formates and derivatives represent approximately a $700 billion slice of the $3.5 trillion global chemical market, including existing formate markets and emerging formate derivative markets. Once you have an energized CO2 molecule, it's very downhill and process economic to synthesize a wide variety of other types of molecules. Our go-to-market is straightforward. We just make and sell chemicals and partner with industrial companies with tax equity and CO2 abatement concerns to generate a highly profitable product that we then return profit share to the industrial CO2 emitter and sell the product to commercial customers who want clean, distributed, low-cost hydrogen, carbon monoxide, or green chemicals. Traction-wise, we've scaled the electrolyzer by 1,500x in just 3 years. We are now at 1.5 square meters. We've secured 18 patents and won multiple contracts and grants, raising over $12.5 million to date. We've also recruited the world's foremost CO2 electrolysis engineers, brought them all to Richland, Washington to focus on formate production.
I'm afraid I have to stop you there.
All right.
Sorry.
Thank you.
Thank you very much. Jury, you have 2 minutes for your questions.
Can you share more about the cost and cost reduction potential as you scale?
Yeah, well, today we're 30% cheaper than the incumbent CO2 carbon monoxide-based process for making hydrogen formate. And that's with a relatively low current density of 125 milliamps per centimeter squared. We can approximately improve that by 4x theoretically over the next several years. And so, and with subsidies, we expect our long-term costs to be on the order of $100 a ton, which is about 1/5 the current cost of production using fossil-based methods.
And have you found a way to monetize the negative emission element?
There was multiple ways to monetize all of our process, because we not only make green hydrogen in the process of valorizing and reducing CO2 reduction, but we also generate substantial carbon credits through the abatement process.
Can you help us understand the CO2 purity that you need as a feedstock and then the overall energy consumption of the process?
Yeah, so we obviously we prefer a high purity source of CO2 as possible. That tends to come from fermentation-based processes today that generate high purity CO2. That's where we're based in the United States. We have 220 bioethanol plants that just emit high purity CO2 directly into the air today there, and it's available at very low cost. But we can also take CO2 from any kind of carbon capture type of system, and we're partnering right now with direct air capture and flue gas capture CO2-based technologies.
Can you tell us a little bit more on the commercial traction that you generated?
Yes, that traction slide appeared very, very slowly. Yes, we have 3 customer contracts right now to deliver formic acid, both one as a carbon monoxide carrier, one as a hydrogen carrier, and one as a CO2 carrier. Our investors include oil and gas companies and climate companies. We provide the way basically to make liquid form syngas at any location with low-cost electricity sources, transported as a conventional liquid across the world, and deliver sustainable carbon and hydrogen precursors for making e-fuels, synfuels, and almost any kind of organic chemical that you can imagine.
Thank you very much.
Thank you.
Thanks.
1 second. 1 second. Sorry. 1 second. And next up, Mathias Bösl, CEO and co-founder of Spark E-Fuels. Remember, you have 3 minutes, and good luck.
Yeah, thank you. So 2 days ago, actually, when I started my trip to Bilbao, I had a look at the CO2 emissions of my flight, and believe it or not, I already consumed more than 10% of my yearly CO2 budget. And if you had to take a intercontinental flight, unfortunately, it's already your full CO2 budget. And all of this adds up to about 4 to 5% of CO2 emissions or global warming coming from aviation. And even worse, aviation is very hard to abate. Like you have the existing infrastructure, you have the existing fleet, and unfortunately there's no alternative to combustion. But we are in a green molecules session, so there's a good solution to it called sustainable aviation fuel. And these sustainable aviation fuels, they are drop-in, so you can use them in the existing infrastructure. Don't have to exchange anything. And they are sustainable because they are produced sustainably. You first store CO2, convert it into a fuel, then release it again. Problem with these fuels is just they are still way too expensive, especially because the electricity and the input factors are too expensive. And unfortunately, there's also expected to be a pretty big gap because of the scalability of the technologies. So that's exactly where we are working on with our load flexible e-fuels SAF production technologies. So what we need as an input is captured CO2, that's one thing, and the other thing is hydrogen, optimally produced from electricity, green electricity directly from solar and wind. And then we developed two specific conversion steps. One is a reverse water gas shift conversion step, which takes CO2 and H2 and converts it into a syngas. And the second one is a Fischer-Tropsch conversion step. So both reverse water gas shift and Fischer-Tropsch are known processes, but what we specifically do is flexibilizing these to really be able to cope with this fluctuating production of hydrogen and also this fluctuating production of green electricity. And especially with the reverse water gas shift, that's a very disruptive technology that we are developing there because it has a very high conversion from CO2 and is completely load flexible. So with all of this, what you gain is a lot of cost reduction. You also gain fast scalability, and it's extremely sustainable when the input factors are sustainable. So to get to a commercial plant as fast as possible, we are parallelizing our development. For the reverse water gas shift, we are doing this completely on our own. Already have done a lot of lab development, secured the IP on it, also licensed in an IP from a university, and currently are starting with the pilot plant. And the second thing, what we are doing is we are developing and flexibilizing the Fischer-Tropsch reactor together with a corporate partner. And there we are already preparing a proof of concept and then also a demo plant together with them. So that means the team behind all of that, that's the three of us. We have extensive experience already in company building, in these green molecules from BASF, from BCG, and also in startup building. So if you want to relax on your next flight, not enjoy your chicken and pasta and not think about CO2 emissions, join our vision of sustainable aviation. Thank you.
Thank you. Remember, jury, you have 2 minutes for questions.
There are other companies who are working on the same thing. For example, Lydian. Can you talk through your kind of innovation? Lydian Labs?
Yeah, really depends on, like, reverse water gas shift is a name for a reaction, or the Fischer-Tropsch is a name for a reaction.
I understand. Yeah. So there are other companies who are working on reverse water gas shift reactors that are able to do like high conversion of CO2 to CO and H2 and able to run also flexibly that can ramp. Can you talk through, I guess, what your, the particular features of your reactor are? What is really like enabling there?
Yeah, I will not tell you the particular features of the reactor, but the thing I can tell you is the one thing is our process is completely load flexible, so it separates CO2 and H2, so there cannot be any reaction between the two. That's one thing. The other thing is it's at a very high conversion rate, so it's over 90%, it's almost full conversion. So the nice thing about this is that you actually don't have to feed in any CO2 into the Fischer-Tropsch reactor anymore. So it's completely load flexible. The other thing is it's at lower temperatures. So and then really depends on what exact technology you're looking at. There's specific differences between the different of them or not.
Yeah. Then can you tell us a little bit more on the price point with scaling up that you project to reach? Probably not yet, but like what's in it?
Yeah, that's always a good question. With e-fuels, obviously it's supported by the government. A regulation is around it because it's expected to be much cheaper than biofuels in the future and almost in par with fossil. Will never reach fossil. So what we calculated is that our fuel will be around 1.5 to 2 times fossil fuel. If you add emission cost on the fossil fuel, then you're actually on par almost with it. Yeah. Thank you.
Thank you very much.
Thank you.
Thank you for a captivating round. Now you'll be happy to hear we head into our lunch break. During this time, don't miss the opportunity to interact with peers, make new connections, and get ready for the upcoming pitches we have after lunch. One last thing, for your information, for those interested in participating in next year's EdTech Summit, swing by our booth in the Expo Zone if you want to secure your sponsorship packages, okay? With a nice discount, of course. Thank you. Enjoy your lunch. See you. Please be back here by 2 o'clock, okay? Thank you very much. Enjoy your lunch.